Hi everyone, welcome to this comparing coefficients video. It's my first video, so please forgive the long pauses and poor editing. Hopefully you will understand the concept by the end. However, if you just need brushing up with this technique, feel free to use these timestamps here to move around the video. I just wanted to clarify what exactly are coefficients. So here I've got a list of terms. As you can see here I've got 4x squared, 10x and so on. And I just wanted to make it very, very clear that the coefficients are the numbers which are attached to, or glued to, if you like, glued to the variables. So the variable, for example, in this first example, is x squared. That's our variable. And the number attached to that is 4. And so 4 is our coefficient. And 10 will be our coefficient for this example. And what the coefficient tells us is the quantity of this variable. So we have 10 x's, for example, here, 4x squareds here, and 500x to the power of 4s here. Now this is something I did want to talk about as well. 500 is a constant, but it could also be considered as a coefficient because it's technically the coefficient of x to the power of 0. Now x to the power of 0 is invisible here. It's basically lurking around here in the shadows. You don't see it because what is x to the power of 0? X to the power of 0 is just 1. And so you don't write it here, basically. So you wouldn't see it. You just see a constant, 500, for example. But just so you know, yeah, this is also a coefficient, even if it's a constant. So hopefully that's cleared that up, and you now know why this skill or why this topic is called comparing coefficients, because we're just going to compare, for example, the 4 in this 4 for this x squared term against another x squared term, which might be a or some letter, and you'll see that in the examples in a minute. Alright guys, so here's our easy example, or a simple example. I don't want to be harsh to anyone. The reason why this is a simple example is because we don't have many terms here to start with, and we don't have many types of terms. For example, we only have an x term and a constant term on each side. So here's our x term, here's our constant term, here's our x term, here's our constant term. So not much really to compare. So let's start by talking about this equal sign in the middle. If you have, for example, let's say you're selling apples or bananas and you have 2 tables and you want to keep the same amount of apples and bananas on each table. You want to have the same amount at all times. At all times you want to have the same amount of apples on both tables and the same amount of bananas on both tables. And so if I showed you one table and I said, here, look, you have 10 bananas on this table. How many bananas do you have on the other? The answer would be 10. You must have 10 on the other side. And the same goes for the apples. If I said you have 5 apples on one table, you would have to have 5 apples on the other, because I've told you that they are equal to each other. This is what this equal sign is doing. It's doing exactly the same thing as that. And in apples and bananas, you can think of this as your apples, as your x term, your x's essentially, your x's, and your bananas. And here you have your other apples on the other table, and your other bananas. So you must always have the same amount on each side. So let's go ahead and do some comparisons, some direct comparisons. I'm sure you all know, or actually I don't want to assume that, I'm sure some of you will know now the answer to this question. First, let's compare our x's together, or our apples, if we're going to relate this back to that example. So when we're doing an x comparison, 2x must be equal to ax. That must be true. Otherwise, that equal sign would be invalid. It would not be true, that equal sign. So 2x must be equal to ax. Now if we divide both sides by x here, we end up with 2 equals a. That's it. That's your first comparison. Now let's go ahead and compare the constants together. So on the left we have a constant of 5, and on the right we have a constant of b. B is a constant because it doesn't have an x next to it, or it doesn't have an x squared next to it, or an x cubed. It's just b. It's just a number. It's not related to a variable. It's not glued together to some variable. So if we're doing a constant comparison, 5 must be equal to b. And we can't take that any further. That's the only thing we can say about this. 5 must be equal to b. And there you go. Now you know what a is, and now you know what b is. Okay guys, so here's our sort of medium example. And the first thing we're going to do here is examine this equation that we have. Now as it stands, this isn't really ready for us to make a comparison on, because they're just too different. I mean, there's, you're going to have to think a few steps ahead, which is what we're going to go through obviously now. But you're going to have to do, you have to sort of predict some things and do basically too much in your head and risk making an error if you want to compare at this stage here. So instead of that, what we're going to do is we're going to make them look more similar. And what I'm talking about is the left side and the right side. I want to make them look, oh, that's not how you spell right. I want to make them look more similar and, if possible, directly comparable. So here we go. So our first step was to examine this equation, and now our second step is going to be to expand and simplify this. So if we expand the left-hand side, because that's the only place where we have brackets, let's go ahead and expand this. So we're going to have 2x squared minus 10x plus 3x minus 15 plus 7. I'm just going to move that over to the left a little bit. And it's going to be equal to our right-hand side, which we haven't changed at all. Now, there's a bit of work we can still do on this left-hand side here. We can simplify this and this. So let's go ahead and do that. That is, God, what is that? There we go. So now we have a simplified equation. Let's double check this. Yeah. Okay, so now we have our simplified equation. Now, these two sides, the left-hand side and the right-hand side, are much more comparable now. So our equation looks ready to make comparisons on. So let's be disciplined and structure this properly. First, let's compare the x squared terms. For the left and right sides of the equation to be equal, they must have the same amount of x squareds. So how many x squareds do we have on the left? We have 2. How many x squareds do we have on the right? Well, that hasn't been, we don't know yet. We don't know. But they must be equal. So if there's 2 x squareds on the left, there must be 2 on the right, which means that when we make our x squared comparison, 2x squared must be equal to ax squared. These two things must be the same. Otherwise, this equal sign that you can see here would be, wouldn't be valid. So in order for that equal sign to be valid, these two terms need to be equal. And so we have this equation, we have this equation here that we've sort of built from our observations. And what we're going to do is we're going to divide by x squared on both sides, just to get rid of the x squared. And we're going to be left with 2 equals a. So we found out what a is. And you're going to do the same thing with the x term. So how many x's do we have on the left? We have minus 7. And how many x's do we have on the right? We have b. In other words, we don't really know yet. But they must be the same. And so minus 7x must be equal to bx. I hope this yellow is coming through. So I'm going to divide by x both sides. I'm going to be left with minus 7 is equal to b. And then lastly, our constants. So our constant comparison. In other words, fixed numbers, or sort of terms which are just fixed numbers. Constants is what we call them. They don't have an x next to them, or an x squared, or an x cubed. Just a whole number. Well, could be a decimal technically, but yeah. So constant comparison. What do we have on the left? We have minus 8, and this must be equal to c again. Otherwise, this equal sign is not valid. And so c must be equal to minus 8. And there we have it. Now we have all three letters. And this is you can see this is the comparison. This is the comparison part of comparing coefficients. Okay guys, so here's the harder example I'm going to show you. Now clearly the reason why this is a bit harder than the previous one is because of this fraction, if you like, on the left hand side. Now that might put a lot of people off and make them think a bit too hard about this question, but really there's not a lot going on here. So what we're doing right now is we're examining our equation, and we can see, as I've said, that we have a fraction on the left hand side. But we can make this a lot easier, and so the next step is going to be to rearrange this equation to make them the two sides more comparable, just like we did in the previous question. This time we are going to multiply by this x plus 2 down here, and the reason why I'm going to do that is because that will get rid of the fraction. That will remove the denominator from the left hand side. So if I just go ahead and do that, as you should know, if you don't, I'll make a video on this as well. But if I multiply both sides by x plus 2, on the left, what you're going to find is the following. These x plus 2's are going to cancel out, and what I'm going to be left with is just this equation here. And I'm just going to scroll up just so we remove, actually pause it there if you want to have a look at that working out. But I want to talk about this equation here, this line, I suppose. It's the exact same equation, by the way. We have not changed anything. As long as you multiply both sides by the same thing, or as long as you do anything to an equation, as long as you do it to both sides, you're not changing the equation at all. You're just moving things around. Yeah. Anyway, as you can see here, we've removed the fraction. We've got rid of it. There's nothing on the bottom. Obviously, there's an invisible, there's an invisible 1 underneath as a denominator, but nothing serious, nothing to put you off. Anyway, what's the next step? Notice how we are coming quite close to being able to clearly compare the two sides of our equation. The only thing left in our way now is to expand the brackets on the right hand side, these ones. So let's go ahead and do that. Right, so here we go. I've expanded those brackets because I can see that we have a quadratic equation, well, quadratic expression, if you like, on the left, and these two brackets will also give me a quadratic expression, as you can see just there. So I'm going to have now you can see that these two things are very, very similar to each other, and so we can compare them because of this equal sign. Let me write this down. Let me bring this down here. So now, here we go. This is now the same level as the other questions that we've been doing today. But as we've been doing, let's first compare the x squared terms together. So on the left we have ax squared, and on the right we have x squared. That means when we compare them, they must be equal to each other because of this equal sign. And if I divide both sides by x squared, I end up with a equals 1. And now, if I compare the x's together, I find nothing. Well, I'll show you what I find. I find this, which doesn't tell me anything because there's no letter there. There's nothing to find there in that comparison. But notice how this is still true. This is nothing wrong is going on there. It's just doesn't provide any information for us. And then lastly, the constants. Minus b must be equal to minus 2. And if we multiply both sides by minus 1, we find that b must be equal to 2. And then we have it. We have found a and b. So just to quickly run through that, what were the hardest parts of this question? What made this question harder? Well, definitely the fact that we had a fraction right at the top here, which I'm just going to highlight in. Just going to get my highlighter out in blue. This one over here. That's what makes this question hard. But we quickly dealt with that situation by doing this operation here, by multiplying by the denominator. And you can see the cancellation here. And then here, we are back to sort of the same level the other questions were. So nothing new from here on. There's nothing really new. It's this section which makes this a harder question. Thanks for watching, everyone. Hope you enjoyed that. If you did, give me a thumbs up. If you didn't, thumbs down. Comment what you would like to see improve and also what you like the most. Stay safe.